Hello and welcome. I'm Dr. Sukhpal and I'm very excited to take you through the LPU's inspiring journey to space. I'm very thrilled to share with you something extraordinary that not many of the university can proudly speak of. At LPU, we don't study space sciences. We build technology to reach space. The students over here not only dream of space, they actually build technology. They build satellites. Our students are working on real-time projects that can one day orbit around the system. They design and develop systems that can orbit around the Earth and beyond. So, if you are passionate about space, innovation, and technology, you are in for a treat. The universe has always fascinated humanity, from the ancient astronomers or the ancient sky watchers to the ancient astrophysics that explore the depth of the cosmos. At LPU, we believe that the next frontier in innovation will be space, with India's space sector opening up for the private as well as the academic partners. Thanks to the initiatives like ISRO, InSpace, and all others, LPU think this as an emerging opportunity to empower our students. So we have built a center of space sciences over here, which is a multi-interdisciplinary. We have established a center of space sciences, a unique interdisciplinary initiative where the students from electronics, electrical, aerospace, mechanical, and core sciences come together to experiment, learn, and innovate things in the field of satellite technology and space sciences. Taking this initiative further, we have built a LPU ground station on campus equipped with modern state-of-the-art facility that enables real-time data reception, decoding, enabling our students an opportunity to work over real satellite data. So making this space truly accessible to our students. What makes this initiative more special is it is not just theoretical. Our students are involved in real-time projects. They are actively building CubeSats, nanosats, even CanSats. Few of you can see they are placed at my back. These satellites are miniature satellites that mimic the major larger systems. Making the satellites, the students learn how to basically, in these projects, students explore telemetry and data communication, payload system design, power management, how the power is managed in the outer space. Even the launch simulators, using the industry-grade simulators like STK, MATLAB, and the Kubelet simulators are used. So what is even more inspiring is these projects are student-led, and the faculty act over here as a mentor. And this is a real-time example of the classroom meeting the cosmos. Now, student satellite team have already achieved recognition in various forms. The students have participated in national level competitions. These are the few satellites that are designed by our students. They are not actually we can use these as an industry grade material, that is space qualified material also, which can one day orbit around the Earth, even beyond. So these are all student made. They have integrated the processors that can measure the space, as well as the process those information gathered over there. That is performing an experiment somewhere in the space. So this was one of the student and they have won multiple competitions based upon these. There are few that has already designed a solar sail placed over here. This is a rover design. All these systems are basically designed by students, where faculty act as a mentor and making an environment of learning within the classroom. Okay, so this is one of our initiative. Moreover, we have this satellite lab, a ground station lab, which has the capability to record weather satellites, majorly NOAA. So we can collect data, process those, and use that for the further research also. And we are utilizing that also. I will be showing you in hands-on training related to this in a meanwhile. Now, as I talked, we can track multiple satellites over here. Multiple satellites, now we are able to track the NOAA series. Actually, there are 5 in number. So, starting with NOAA 15, 16, 17, 18 and 19. All these works on VHF bands. Now, they give us an audio image, and if you can see, this is a NOAA 15, which is moving around the Earth on the polar axis basis. And the Earth is moving in this direction, as well as they are orbiting in the polar orbit. So, it gives us this direction, the way it will be going. So, if you can see, the software can give us the information when we will able to track this signal, this satellite. Now, if you can see this white area gives us the acquisition of signals. That is the actual time where this satellite is broadcasting some information. That broadcasting signal we can receive. This signal is in the form of an audio waveform, and we use a different software, that is WX to IMG converters, which make this audio file, decode this audio file and convert that into a one automated picture transmission case, that is an image of that particular feature. And we get multiple enhancements over there with which we can receive the signals. The transmissions can be used for thermal imaging, precipitation data, humidity data, the cloud information, the formation of clouds, and the direction in which they are moving. So, this is actually the ground station where we are, the lovely professional university. If you can see this home page, this is where we are sitting, and this is the area. This area is basically 2,500 kilometers through which we can receive the images. And this work on VHF very high frequencies, that is 137. We have the series, the NOAA 15, NOAA 16, NOAA 17, 18 and 19. All works with a frequency band of 100 megahertz. Okay, these are the images. Now, when we receive that information, the information is then converted into an image. This is a very beautiful image that has been received. This is after the receiving, we tracked this NOAA 18. From the NOAA 18, we downloaded our wave file. Now, using that software, we converted that wave file into an image. This shows a very beautiful images of the clouds, the precipitation areas across India. And we can, this area was covered by NOAA 18 on this requested date. We can see other images too, like this thermal images, which is converted in the form of the temperature at particular areas, the precipitation data, even the sea data images can also be retrieved. These are the different enhancements that we can apply one particular wave format that we have received. So, this is the way we actually receive the data, decode it, and further use for our research work purpose. Even the students get an exposure how to work on, they learn how to receive the signals, how to decode it, and how to utilize that data for their research purpose or any application thereafter. So, if you are someone who looks at stars and think, I want to be a part of it, LPU is where your journey begins. So, hope to see you soon, not as a student, but as a future scientist, an innovator, as well as a space explorer. Thank you.